14.4 is the flaws of apportionment methods. So remember, we have our four methods: Hamilton, Jefferson, Adams, and Webster, but this is going to talk about the flaws. We've got a couple of paradoxical statements here: Alabama paradox, population paradox, and new states paradox. And you're going to have to pay real close attention because it's very specific of when it might happen. Alabama paradox occurs when an increase in the total number of items to be apportioned results in the loss of an item for a group. Population paradox, when group A loses items to group B, even though the population of group A grew at a faster rate than group B. And the new states paradox happens when the addition of a new group changes the apportionments of the other groups. So think about increase in the total number of items, population of group A grew faster, and addition of a new group. That's kind of the three different things that you would need to look at. Belinsky and Young's impossibility theorem. There's no perfect apportionment method. Any apportionment method that does not violate the quota rule must produce paradoxes, and any apportionment method that does not produce paradoxes must violate the quota rule. So it's just saying there's no perfect way to do it. Let's get to an example. Example 1, a small country with a population of 10,000 is composed of 3 states. According to the country's constitution, the Congress will have 200 seats, divided among the 3 states according to the respective populations shown in the table. Part A says use Hamilton's method to apportion the 200 seats. Hamilton's method. All right, well, first we want to find that total. And I'm going to add those numbers up: 5,015, 4,515, and 470. That adds up to 10,000. That's the total. So when we do Hamilton's method, we want to start with that standard divisor. Remember, the standard divisor is the total population divided by the number of items. In this case, the total population is 10,000, and the number of items was 200. Divide, we get 50. 50 people per seat. Or in other words, 1 seat for every 50 people. So that's our standard divisor. Divisor means we're going to divide by that number. So we divide by that number, and we get 100.3, 90.3, and 9.4. Since this is Hamilton's method, we know we're going to round down. We round down 100, 90, and 9. If you add those numbers up, that only adds up to 199, and we're supposed to add up to 200. So that means we've got 1 surplus item. You give out that surplus item to the highest decimal number. That would be this 0.4. So we're going to give out that 1 surplus. And that means Hamilton's apportionment says A has 100, and B has 90, and C has 10. There's your 200 items. That's Hamilton's apportionment. Part B says a change in the country's constitution increased the number of seats to 201. Use Hamilton's method to apportion the 201 seats. So it's very similar calculation, except this time when we find that standard divisor, you're going to take the total number of items divided by 201. And that's about 49.751. That would be our standard divisor. So we take those numbers. A had 5,015, B had 4,515, and C had 470. And we're going to divide by that 49.751. When we divide, by 49.751. I get 100.8, 90.75, 9.45. Hamilton's method, we're going to round down. That's 100, 90, and 9. Adding those up, again, you get 199. But remember, we're trying to apportion 201 seats. So that means there are 2 surplus items this time. You give those surplus items out one at a time to the highest decimal place. Well, the highest number is this, and then the second one would go to the second highest decimal. Hamilton's apportionment then would be A gets 101, B gets 91, and C gets 9. Part C says, if a paradox exists, tell which one and briefly explain why this is paradoxical. If we go back and look at the definitions, the Alabama paradox says when an increase in the total number of items to be apportioned results in the loss of an item for a group. That's exactly what happened. We went from 200 to 201. But that resulted in the loss of an item for a group. Check it out. We increased the number of items to be apportioned, but C went from 10 to 9. That seems like a problem. That's a paradox. That is the Alabama paradox. As far as explaining this, you almost want to just reword the definition. C lost an item. An increase from 200 to 201 items to be apportioned results in a loss of an item for C. Number 2, a small country with population 10,000 is composed of 3 states. There are 11 seats in the Congress, divided among the 3 states according to their respective populations. The table below shows Hamilton's apportionment of congressional seats for each state. So a couple of things here. First of all, the table is written sideways instead of sideways, it's written up and down. And so the normal table is sideways from this, but those are the important numbers that we would need if we were doing Hamilton's apportionment. But they already did Hamilton's apportionment, and they found A gets 0, B gets 3, and C gets 8. So the work has already been done here for Hamilton's apportionment, but we're going to change something. The country's population increases by 1,000 people, as shown in the table below. Find the percent increase in the population of each state. Percent increase, you would have talked about in algebra class, or percent change, whether it's increase or decrease. But the percent change, in this case increase, is always going to be change over original. That's how you would find the percent change, the percent increase. So what I'm talking about there is for A, it changes by 20. And you didn't really need to show the work there, but the next one's a little bit harder. 2550 minus 2430. do that subtraction problem, and that gives me 120. And then that third one, the change, it goes from 7890. Actually, I said that backwards. It goes from 7,030 to 7,890. But that change is a change of 860. That's the change. So divide that by the original. So 20 is the change divided by the original number 540. 120 is the change divided by the original number 2430. 860 is the change divided by the original number 7030. Change over original. When you do that division, 20 divided by 540 gives me 0.037 or 3.7%. The next division, 120 divided by 2430, is 0.049 or 4.9%. And then the last one, 860 divided by 7030, is 0.122 or 12.2%. Those are the percent changes, percent increase. Part B says, if a paradox exists, tell which one and briefly explain why this is paradoxical. So we're talking about the population increases and the percent change. So let's look back at the definitions again. Population paradox says when group A loses items to group B, even though the population of group A grew at a faster rate. Okay, so you got to think about the percent increase when you're talking about growing at a faster rate. So we can see that group C grows the fastest. It's growing at the fastest rate, followed by group B, and then group A is the slowest, I guess. They're all growing, they're all increasing, but you can tell that C is fastest, next is B, and then is A. So if a paradox exists, tell which one and briefly explain why this is paradoxical. Well, we're going to have to find Hamilton's apportionment. But remember, we changed the numbers, right? The one that they did for us was with 10,000, but now we're increasing to 11,000. So we've got to start over, but we've got to use those numbers with the 11,000. All right, so let me just copy the table so I can scroll up. We need to do Hamilton's apportionment and see what happens there. Hamilton's apportionment. We're passing out 11 seats, so let's calculate the standard divisor. The total population is 11,000 divided by the number of items, 11. That's 1,000. 1,000 people per seat, or one seat per 1,000 people, I suppose. Let's divide. We're going to divide by that standard divisor. And we get 0.56, 2.55, 7.89. Hamiltons, we're doing Hamiltons again, so we round down. That's 0, that's 2, that's 7. That only adds up to 9. Looks like we should have 2 surplus items. Give them out one at a time to the highest decimal point. So this one gets 1 for being the highest, 0.89. 8. And then next is 0.56. 1. So Hamilton's apportionment says A gets 1, B gets 2, C gets 8. But that's not the question. The question says, if a paradox exists, tell which one. Is that a paradox? Is there a paradox here? A gets 1, B gets 2, and C gets 8. Originally, remember, before the change, It was 0, 3, and 8. Okay, so what does that mean? A now has 1 instead of 0. B has 2 instead of 3. If you notice, B lost 1. B had 3, now they have 2. B lost 1, but A gained 1. But what you're supposed to do is you're supposed to notice that B's population is growing faster than A's population. Well, that's that population paradox. Population paradox. Go back and look at the definition if you need to. Population paradox is when Group A loses items to Group B, even though the population of Group A grew at a faster rate than Group B. This is exactly what it says. B's population grew faster than A's, but B lost a seat to A. That is the population paradox. Number 3, school district has 2 high schools, East and West. East has enrollment of 1688, West has enrollment of 7912. The school district has a counseling staff of 48 counselors who are apportioned to the schools using Hamilton's method. This apportionment results in 8 counselors assigned to East and 40 counselors assigned to West. So they've already done all the math, they've already done Hamilton's method, and we see East gets 8 and West gets 40. Part A says find the standard divisor, then tell what this means in the context of the problem. So remember, standard divisor is the total population divided by the number of items. Total population here, I guess, is this 9,600. And we are apportioning, how many was it, 48? 48 counselors. When you do that division, that's 200. And the standard divisor is 200. Then tell what this number means. Well, look at the units. 9,600 was people, and 48 was counselors. So it's 200 people per counselor. Or, in other words, 1 counselor per 200 people. Sometimes I think it's easier to understand when you look at it that way. But this is the standard divisor, 200. 200 people per counselor. Part B, suppose a new high school, North High, with population 1448 is added to the district. Using your result from Part A, how many counselors should North High have? Okay, well, North High has 1448, and we know there's supposed to be 200 people per counselor. So just a kind of a quick, simple estimation, it tells me that this should be about 7. There should be about 7 counselors. And I don't want to get any more accurate than that. Obviously, there'd be a decimal, but we can see that it's about 7. 1,400 divided by 200 is about 7. So 7 counselors for North High. Part C says the district hires 7 new counselors. What a coincidence. Use Hamilton's method to reapportion the counselors. So now we have 7 more. There were 48, now there's 7 more. So now we've got a total of 55 counselors. We've got to apportion those 55 counselors. Now I didn't give a whole lot of room here, so make sure you write small. East High had 1688. West High had 7912, and North is the new one, North High 1448. If you add those three numbers up, that gives us a total of 11,048. 11,048. All right, so if we're going to do Hamiltons, that's east, that's west, that's north. If we're going to do Hamiltons, we need to find that standard divisor. Standard divisor is the total population divided by the number of items. When I do that division, that gives us about 200.87. Standard divisor is 200.87, or 200.87 people per counselor. We're going to divide by that. This is Hamilton's method, after all. Doing that division gets me 8.40, 39.39, 7.21. And we're doing Hamilton's method again, so again, we're rounding down. Keep in mind, if it was a different method, maybe we'd round up or round nearest, but Hamilton's always rounds down. Round down to 8, 39, and 7. 8 plus 39 plus 7 is only 54. So we can see there's one surplus item that we have to give out, and we're going to give it to the highest decimal point, 0.40. So add that on, and east gets 9, west 39, north 7. That would be this Hamilton's apportionment. Part D says, if there's a paradox, tell which one and briefly explain why this is paradoxical. Well, if you read the definitions, it should be obvious that this is going to be new states. But like, really go back and read that definition. The addition of a new group, well, yeah, that's what we did, changes the apportionments of the other group. So this is kind of what you have to make sure that happens. Did adding a new group change the apportionments of the other groups? I bet it did. So check it out. At the beginning of the problem, East got 8 and West got 40, but now East gets 9 and West gets 39. So that's kind of weird. We added 7 new counselors for this new high school. Why should that change the apportionment of the other schools that were already there? The addition of a new school caused the apportionment of East and West to be changed from 840 to 939. Last slide is kind of a summary and what could happen, when it will happen. Check it out.